Hey everyone, this is Barak from Ionir. In this next video, I will demonstrate how easy it is to burst and migrate MongoDB with Ionir Teleport. Let's get started. In the demo setup, we have two Kubernetes clusters, both with Ionir installed. On the first cluster, which represents our on-prem data center, we have a demo MongoDB instance. There is also an arbiter. The second cluster, which is our cloud-based cluster, has no workloads at all. This is our on-prem environment. Let's review our services and pods. We can see that the MongoDB application is running and has an external load balancer. On the cloud cluster, we can see there's only an external load balancer configured with no workloads. Let's execute into the MongoDB pod on our on-prem cluster and review our data. We can see we have testDB, which contains 14 gigabytes of data. Now let's review the MongoDB replica set members. There is a primary MongoDB node with its load balancer address and an arbiter service. In addition, there is another node, the secondary MongoDB node, that is a non-reachable, not healthy state. This is because it does not exist. We haven't created it yet. Before we create that node, let's review the DNS failover routing policy for the direction of the connection between the primary and the secondary node. On the Mongo client, we can make a connection using that virtual address to the primary node. As you can see, all of our data is here. Now let's create the secondary MongoDB node on the remote Kubernetes cluster. We start with teleporting the MongoDB volume to the remote cluster. The operation takes less than 40 seconds to complete, and the volume is now available on the remote cluster. Let's take a look at the copy of the volume that was created by Teleport. The PVC has already been created, and now we can deploy our MongoDB application YAML. The MongoDB app is running, and we can execute into the pod. The data is available on the remote cluster. We need to wait a few moments just for the remote node to get synced with the master. The node now is in a sync and in a secondary state, which means that it has joined successfully to the replica set. It can start serving queries and support the failover scenario. To demonstrate this failover, let's go back to the primary node of the MongoDB replica set. First, we will reconfigure the priority of the remote node to 101, which is instantly making it the primary node. As you can see, the remote node now is the primary. If we open the MongoDB client, we can see it still points to the first node, which is our secondary node now. In order to complete the migration and the failover, we will delete the service at the first site. That triggers the DNS failover routing policy we discussed earlier. Now that's done, let's dig into our public DNS record that will show us the backend DNS name that gets resolved. It will take around 1 or 2 minutes to complete the failover based on the way that we have set up the DNS failover policy. We see the public DNS name now redirects to the primary node, which is our remote copy, and all of our data is there, ready for read and write operations. We can see that the first cluster node is no longer reachable and no longer part of the replica set. Back to Ionir UI, we can see that although the MongoDB application was fully migrated, only 10% of the data was actually moved between the clusters. This concludes our demo. We have seen how easy and simple it is to move applications and data between Kubernetes clusters with Ionir. Ionir makes the hybrid and multi-cloud vision a reality. Thank you very much and see you on the next demo. Bye-bye.